Hello, this is presentation number 3 in the Advanced Networking course. Today I'm going to talk to you about securing the switch and what we can do about that. First of all, it is a good idea to shut down all the ports in the switch that you are not using. Then, if you want to configure the switch using the network connection, well then it is a good idea to use SSH instead of Telnet. Because if you're configuring using Telnet, you are sending the passwords and all the traffic unencrypted over the network. And if you want to be more secure, then it is a good idea to use SSH. You will use it in the same way as you use Telnet. You use a command line protocol to send the information back and forth so that you can use the iOS and configure the switch remotely. SSH uses TCP port 22 by default, and Telnet uses port 23. So when you connect to a switch using the network, well then you just are prompted for a username and a password, and then everything you send back and forth in this communication will be encrypted. So how do we set it up? Well, there are some basic things that need to be present to be able to run SSH. For instance, you need to configure a domain name. And to do so, you use the command IP domain name cisco.com, for instance, or whatever, easv.dk. You just need to have a domain name. Then you generate the crypto keys that you're going to use, and SSH is using the RSA algorithm, and you will generate key by using the command crypto key generate RSA. You can then choose how large a key you want, how many bits you want the key to be. So either 512 or 1024 or 2048. The stronger or the larger the key, the stronger the encryption, but also, of course, slower encryption. Then you need to put in your username and password. By username, admin, password, CCNA, for instance. Then you need to go to your line VTY. In this case here, from 0 to 15, you will allow 16 simultaneous SSH connections. Then you need to say that you want to use SSH instead of Telnet. If you don't say anything, default will be Telnet. So you say transport input SSH and then log in. And then you have actually set up SSH to work. And you can verify it by using the show IP SSH command or just show SSH, and it will show you how you have set it up. Another problem that could occur on a switch is that you have MAC address flooding, because this is programs that are designed to exploit the way a switch works. Because if a switch does not know a MAC address, it will start flooding and behaving like a switch, or like a hub, sorry. So it will send everything out to all ports. And you can actually make the switch do this by setting up sending out a fake or a rogue or a bogus MAC address entry into your switch, and the switch will then start flooding everything out because it doesn't know it. And when it starts flooding, you can go in and you can change the settings so that you can actually set it up to receive the incorrect MAC addresses, so that it will think that your fake address is the correct one, and you can actually start this and set it up as like it will belong or behave like a hub, and you will be in the middle of everything, getting everything that is sent in and out of the network. There are some ways of changing that by allowing just a specific types of MAC address on different ports, for instance. But it's a well-known security breach. I don't know if it's a breach, it's just the way that it functions. Another thing is that also the DHCP is a weak protocol in the way that you cannot really say which DHCP server you want. It's the one that you will get an IP address from. And you can actually go in and set up a fake or a rogue DHCP in your network, and then this DHCP will start handing out fake IP addresses, and these IP addresses will set typically the attacker's computers as the default gateway. So this is also will be like in a man-in-the-middle attack. You can also set it up so that you will not get a DHCP, so you will stop the DHCPs from answering, for instance. And we are very dependent on DHCPs in most modern networks, so it is of course a problem. You can change this, or you can help this from not happening by setting up where on which port your DHCP is present, and then it will go in and see, okay, if I receive a DHCP package from any other ports, that will be a fake or a rogue DHCP server present there. Windows computers that also run DHCP can also be set up to discover rogue DHCP servers, because it is a problem in a network. There are some other protocols that we should also disable if they are enabled. For instance, the CDP protocol, which is the Cisco Discovery Protocol, which is something that all Cisco devices can discover their neighboring Cisco devices on. Then you will be able to see, for instance, if you're connected to a router, you will see all the interfaces, you will see whether they are up and down and their IP addresses. And if you already know that, and you don't need this information to be sent out all the time via protocol, well then you should disable it. Also, disable Telnet. If you want to configure your devices over the network remotely, well then use SSH in all of them and disable your Telnet. So, the best 10 practices from Cisco regarding security is to, of course, have a security policy, shut down whatever ports and services that you're not using, use strong passwords and change them, control physical access to your devices, do not have switches standing out in the open like here, lock them in behind doors, and control the access to them. Use HTTPS instead of HTTP, which will encrypt your web traffic. Perform backups, of course. Educate your employers about all these different types of social engineering attacks and phishing attacks. Encrypt passwords, and yeah, of course, password protect your sensitive data. Implement firewalls and keep the softwares up to date. Of course, the weakest link here is the human factor, so the education of your employers are, of course, one of the main issues here. Yeah, that was it. Thank you.